Hey y'all, what's up? Welcome to FiredHeaterPro. Today we're going to be going over fuel gas properties in the fuel gas module in FiredHeaterPro. You can always just hit calculate all and that'll calculate automatically. But really what you need to do is you need to drill down and make absolutely sure that your fuel gas properties are right. If they're not, your simulation's going to be wrong. It could result in unnecessary capital cost, or worse, it could result in draft problems or even failure to hit duty. So let's dive in. All right, we open our fuel gas properties module. We've got air properties. This is pretty typical numbers here. You're welcome to change it if you want. One thing to keep in mind is that we usually model these heaters on an excess air 15%, but you can change that if you wish. Some people use 10% for a forced draft heater. Our fuel properties module, this is kind of really the meat of the module. We do have the ability to model liquid fuels like diesel. It's very uncommon nowadays for those to be used. Most localities won't grant a permit to burn diesel anymore in a fired heater. So 99% of the time you'll be using gas fuel. Down here we've got the components total. This tells you what the total is of the components that you've entered for your gas fuel. Personally, I like to see it hit 100, but something to bear in mind is that when you hit that calculate button, FiredHeaterPro is going to normalize it to 100. For example, let's just delete all of the kind of default values. If I put 1 part methane and 1 part hydrogen, hit calculate, we're going to 100%. It's 50 for each. And then over here to the right is where I've got my results. A quick walkthrough of the results. You've got flue gas composition, molecular weight. You've got your dew point. Next up, you've got your fuel gas properties. We've got our lower heating value in both BTU per scuff and BTU per pound. This is a very important value. It's really the key value, I would say, for the FiredHeaterPro simulation, because it's going to use this lower heating value combined with your air fuel ratio, and that's going to tell FiredHeaterPro how the flue gas behaves, what it's composed of, and it's the basis of the heat transfer from the flue gas to the tubes. So that's why it's critical that you get your fuel properties correct before you start simulating and making big decisions. We have a little module here. If you want, you can put in a temperature for your flue gas. At that temperature, you can take a look at the properties of the flue gas. It's not really necessary when you run the FiredHeaterPro simulation. It's going to do that automatically as the flue gas goes through your cabin and your convection section in your stack. However, you can do that yourself if you want, just if you need some numbers for whatever reason as an engineer. A quick word on dew point. Dew point is very important when we're talking about preventing corrosion, both on your fins, your fin tubes, your casing, any kind of ductwork you've got, and even your stack. What drives the dew point higher is typically the presence of sulfur. So if you've got sulfur in your fuel stream, that's going to give you a higher dew point, and it's going to give you a much higher rate of corrosion. So what we can do here is we can add a little bit of sulfur and kind of see how it behaves. And just a very small amount pushed my dew point up by about 70 degrees or so. You can see here when I put H2S as 1% of our fuel gas, we end up with a dew point of over 300. And that's when you're starting to get into a position where you could see condensation and possibly corrosion. So that's all for now for fuel properties. You're always welcome to give me an email at info@firedheater.pro, and I'm happy to help you. Anyway, happy simulating.